All right, before we start, I want to ask you something. You rebased the wrong branch onto main. You already pushed the code. Five engineers in your team already pulled it. What do you do? The one question has ended careers, caused outages, and broken pipelines mid deploy. I have asked the version of it in every senior Git interview I have run. Everyone uses Git daily, commit, push, pull, but ask about rebasing shared branches, reflog recovery, or monorepos, and it falls apart. Today, we fix that. From basics to senior level, that we're going to see the different questions, different concepts, and how we can fix the issues with the Git branching and merging strategy. Think of Git like shared notebook. The whole team writes in. Most people can write in it fine. But the moment two people write the same page or someone tears out the pages other already copied, it turns into chaos. This episode is about staying calm and in control when that happens. If you can answer this opening question by the end of the video, you can handle almost any Git interview. The very basic question is asked in every Git interview, that what is the Git merge and Git re? What is the difference between merge and a rebase? So I'll walk you through 10 different questions, wrong answers, right answers, what are the hiring manager's expectation, and the key takeaways. So this is the question number one, the basic one. What is the difference between Git merge and Git rebase? Both combine work from two branches, but they record history differently. Merge gives the true story. It makes a merge commit that says there are two lines joined here and nothing already saved is changed. Rebase rewrites my branch so it looks like I started from the latest main cleaner. Straight line history, but it creates new commit. I rebase my own branch to tidy it before pull request, and I merge when the work is already shared. The golden rule: never rebase something other people have already pulled it. What can be the wrong answer? Rebase makes history cleaner, so I always rebase. That is the dangerous answer. Rebasing a shared branch rewrites commit other people already have. And force pushing, that is one of the most disruptive things you can do to a team. What are the hiring managers' expectations from this? I am listening for the golden rule and the why. Rebasing changes commit IDs. Teammates still hold the old IDs, so their history splits from yours. Saying that proves you understand it and not just memorize it. Okay. Where to focus? Don't just define two words. Say when you have used each and volunteer the golden rule before you are asked. The single sentence is that separates junior from the senior here. Let's see by the simple examples what we can do and how we can differentiate Git rebase and Git merge. Imagine you and a friend both borrowed the same recipe and each scribbled your own improvements. Merge is stapling both versions together with sticky notes combined here. Here is the exactly what each of us changed. The history is honest and complete. Rebase is neater but sneakier. You you recopy your changes into a fresh copy of your friend's latest version, so it looks like you started from there all along, unless your friend already photocopied your original notes. Now, their copy and your rewritten copy disagree, and that's the maze the golden rule prevents. Don't rewrite pages people have already copied. Okay, let's move to the next question. Question number two. Again, this is the basic question: what is Git stash and when would you use it? What is the expected answer that I expect from every candidate? Git stash puts my unfinished changes aside and gives me a clean workspace without making a commit. It's a stack. I use it when something urgent comes in, a hot fix or a review and I am mid change, I bring it back with the stash pop. One catch: brand new untracked files aren't stashed unless I add hyphen u. What can be the wrong answer? I would just make a commit called WIP and fix it later. Not terrible, but it clutters history, needs cleanup afterwards, and can kick off an unnecessary CI build. So never ever say that for the work in progress changes, we can do the git stash. What are the hiring manager's expectations? Knowing that untracked files need the hyphen u flag and that git stash pop versus apply differs. Tells me you have used the stash for real, not just read about it. What to focus? Mention hyphen u and pop versus apply without being asked. Small specific details are what make an answer sounds experience. Let's understand it by everyday version and the simple. You're halfway through cooking when someone rings the doorbell with an urgent delivery you must handle now. You don't throw the food away and you don't force it into the fridge half made. You sweep everything neatly into a tray and slide it into a drawer so your counter is clean. You deal with the door, then pull the tray back out and carry on exactly where you left off. The drawer is get stashed, a safe temporary place for half done. Question 3, again, it's a beginner level question. Explain the difference between git reset, git revert, and git checkout or the restore for undoing changes. What are the expected answers from the candidate, which can differ the experience and the junior level candidate? Three tools for three situations. Reset moves my branch back to an earlier point. Great for undoing local commits I haven't shared, but never for anything others have already pulled. A revert makes a new commit that cancels an old one, keeping full history. This is the safe way to undo something on shared branch. And the third one is restore or checkout. Just restore brings one file back, an earlier version. Rule of thumb: reset for private history, revert for shared branches, restore for single file. What could be the wrong answer? I would get reset hyphen hyphen hard to undo a commit I already pushed. That yanks history out from under everyone who already pulled it. The right tool for push commit is git revert. What is the hiring manager's expectations from this? The key signal is knowing when not to reset and why revert is safe alternative. Trying the choice to whether the work is shared shows the real operational maturity. Where to focus? Lead is this work shared or just mine? Okay, that one question drives the whole answer. Reset writes, revert record. Simplified version, everyday version. Let's understand what is the git reset. Think of your project history as a diary. Reset is tearing out the latest page. Fine, if it is your private library. Distrust if class already photocopied it. Revert is leaving all the pages intact and writing a new one that says ignore yesterday's entry. Honest and safe when others are reading along. A restore is smaller, still fixing a single smudged page back to how it looked earlier without touching the rest of the diary. Question number 4. This is the intermediate level question. What is the git bisect and how would you use it to find which commit introduced a bug? What can be the right answer, best answer? Bisect finds the exact commit that broke something by playing a smart guessing game. I tell Git one commit that's a bad and one earlier commit that's a good. Git jumps to the commit halfway between them and asks me good or bad. Each answer throws away half the remaining commits. So even 200 commits are narrowed down in about 8 checks. I can even automate it by the command git bisect run dot file location. This lets a test script answer good bad automatically, finding the culprit in minutes. What can be the wrong answer? I would scroll through back git log and read the commits. That works for 5 commits, but for 200 commits across 2 weeks, it's hopeless. And reaching out for it signals you have never hunted a real regression at all. What is the hiring manager's expectation? The automated git bisect run is the tell, knowing you can hand it and test the script, and that have 200 commits is only 8 steps. Signals genuine production debugging. Where to focus? Explain the having idea clearly and mention automation. The concept matters more than memorizing the commands. Let's understand this by everyday version. That's a simplified version. This is the classic guess any number between 1 and 100 game. You never guess one by one. You guess 50, get told higher, guess 75, and so on. Cutting the range in half every time, you corner the answer in about 7 guesses. Bisects does the same with your commit. Say the app worked on the Monday, but it broken today with 200 commits in between. Instead of telling all 200, get checks the middle one, like 100. You try the app still working, then the bug is in the second half. So git checks 150 next, broken there, bug is between 100 and 150. So it checks 125. Each step has what's left. So 8 quick checks pin down the exact commit that introduce a bug instead of enabling hundreds. And if you have tests that can tell works broken on its own, it runs whole hunt for you automatically. What are the conventional commit and why do they matter for DevOps automation? Again, this is the intermediate level question. The right answer, there are simple rule for commit messages. Start with the type like feed, fix, or dot. The tiny label lets tool work automatically. A feed bumps the minor version, a fix bumps the patch, and a breaking change bumps the major version. The change log writes itself from these messages and pipeline can skip deploy for. So the format isn't about the neatness, it drives the automation. What can be the wrong answer? They are just a style guide for writing nicer messages. That misses the whole point. They are machine readable and power versioning change logs and CI decision. What is the hiring manager's expectation? Linking the format to automated versioning and change logs is the senior differentiator. Most know the format, only pipeline experienced people know why it matters. Where to focus? Say the outcome, not the syntax. Feed is equal to minor bump, fix is equal to patch, breaking is equal to measure automatically. That shows you think about the whole delivery pipeline, not just the single label or single word. Let's understand this by simplified everyday version. You're moving house and labeling every box by kitchen, fragile, books, heavy. The movers don't have to open a single box. The label tells them exactly what to do. Conventional commits are labeled on your changes because each change is clearly tagged new feature or a bug fix. The robots down the line are the ones that number you releases and write the release notes and act on the label without human reading the every change. Consistent labeling, automatic work. That helps in the entire CI/CD automation and deployments. Question number 6. Again, it's an intermediate level question. What is the Git hook and how would you use one to stop the secret like password, API keys, or any other secrets from being committed? So again, this is the question from the DevSecOps perspective, how you can enable your check-ins, enable your push to prevent pushing the credentials or the API. I have also made the separate video how to prevent and configure the pre-commit hooks to prevent uh, uh, Git from check-in API keys and passwords. You can go to the API key leak video. I'll also put it in the description and watch how to configure it. Here, what can be the right answer? A Git hook is a little script that runs automatically at a certain moment, and I would use it as a pre commit. It runs instant before a commit is saved. I plug in secret scanner like Git leaks. If it spots something that looks like a password or a key in what I'm about to connect, it stops the commit and warns me, because these scripts don't travel with the repo by default. I share them with the team using tool like Husky or the pre-commit framework, and I back it up with the same scan running in the TI, so nothing slips through. All the commits, all the API keys or the passwords will be cached at the commit time only. What is the wrong answer? Not knowing that the hook live locally and don't automatically reach teammates, or having no backup scan on the server if someone skips the hook. What is the hiring manager's expectations? I want to hear the team sharing problem and its fixed Husky pre-commit framework plus defense in depth. A local check and a server side scan. This is the real team's experience. Where to focus? Keep it concrete. A scanner that blocks the commit if it sees the key. Then add a team sharing and CI backup. Don't drown it in the jargon. So let's understand this by the everyday version, simplified version. For example, you are in a library and you're trying to issue the book from the library. Your librarian checks every book, and if anything forbidden that you cannot take, it will block that. And whatever is allowed, that will be passed through the gate. So similarly, if the pre-commit hook, just like a librarian, checks everything that is forbidden, and it will block that uh, passing through the gate or pushing into the gate. Again, the second check is like at the desk. If anything misses from the pre-commit hook, the server-side scripting, the CI pipeline will check it, so that nothing will be skipped from the scanners, which is forbidden, like API keys, passwords, and things. So first, there will be check at the pre-commit hook locally. Second, it will be checked at the service level. Third, the pipeline also will scan. Now, question number 7. This is the advanced level question. Design a branching strategy for 50 engineers releasing a SaaS product 10 plus times a day. This is also shows the thinking of architecture level and how you design the DevOps frameworks, DevOps environment. What could be the right answer? At that speed, Git flow's long-lived branches would jam everything. I would use trunk-based development with the feature flag. One always working main, tiny branches that lived hours, not weeks, and unfinished feature merges but hidden behind the flag until they are ready. So deploying and releasing are separate acts, and small reviewable PRs required automated checks before merge. Quash merge for clean main, branch protection, and the code owners file so sensitive areas always get the right report. The wrong answer is suggestion for Git flow. Its release and develop branches create bottleneck that makes 10 deploy a day almost impossible. It shows disconnect between the workflow and the deployment speed. And what are the hiring managers' expectation? Reaching straight for the trunk base for plus flag and naming a real tooling, flags, PR size limits, and code. Signals platform maturity. The reasoning matters more than the lever. Where to focus? Anchor on the constraint. First 10 deploys a day plus 50 people means long lived branches will kill us. So reasoning from the constraint is a senior move. Let's understand this by everyday version simplified. Picture a busy restaurant at full rush. Everyone works off one main counter in quick small tasks, plates flying out constantly, half finished dishes sit under the cover like a feature flag. Customer never see them until they are ready. But the kitchen never stops. That's a trunk based development. One shared line, tiny fast changes, unfinished works are hidden but already in place. Now imagine forcing that rush hour kitchen to fill out three approvals from per dish and route everything through the separate preparation rooms. That's the git flow. And it would grind a fast kitchen to a halt, match the process to the piece. So this is the process where tiny changes, where the unfinished changes are hidden, but they are on track. Question number 8, again, advanced question that I asked in the Git interview. How does Git stores its data internally? Explain the object model and why SHA hashes. Right answer, Git is basically a store of objects, each named by a fingerprint of its content. There are four kinds: a blob, files content, a tree, folder listening, a commit, a snapshot pointing to a tree, plus its parent commit and author and tag. The clever part, a commit's fingerprint, it's a SHA, is a build from its content and it's a parent fingerprint. So change anything in the past and every fingerprint after it changes too. The chain is gets tamper proofing. It's why history can be quietly altered, why force push is dangerous, and why commits are effectively permanent. Wrong answer. Git stores the difference between the versions. It actually stores full snapshot. It only uses difference internally to save keys. Believing the myth signals shallows the internal knowledge. What is the hiring manager expectation? This is architect level, connecting the fingerprint chain to the integrity and to why force push breaks everyone else is the answered fully by under 5% of candidates. Where to focus? Nail the chain idea. Each snapshot's ID depends on one before it that signals insights. Explain force push danger, immutability, and why branch protection. Let's understand it by everyday version simplified. Imagine every document you save gets a unique wax seal from its exact content. Change one comma and the seal looks completely different. Now imagine each day's photo of your whole desk includes yesterday's sealed photo inside it. Sealed it again. If someone tries to secretly alter last Tuesday, every seal from Tuesday onwards breaks and no longer matches. The tampering is obviously. That's how Gitlings commit. Each one carries a fingerprint made from its content and the previous fingerprints forming an unbreakable change. It's why you can trust the history and why rewriting shared history is such a big deal. You would be resealing every else chain with your own. Question number 9, again, it's scenario based advanced question. You accidentally committed and pushed an API key to a public repo 3 minutes ago. Walk me through your full response. If you want to answer this question cleverly, watch my another video, API key leaks. The right answer for this particular question will be first and immediately revoke the key at its source, AWS, the API provider. Once it is public, assume it's already copied. Bots can public repos in seconds, so dead key is the only safe key. Then check the access logs to see if it was used. Only after that do I clean the repo, remove it from the history, git filter repo or BFC. Post push and ask GitHub to clear cache copies. Tell the team to reclone, issue a fresh key into the system that need it, and add pre-commit scanners plus CI scanning so it can't happen again. What could be the wrong answer? I would delete the commit and force push to remove it. That doesn't revoke the key, doesn't clear the cached copies, doesn't check if it was already used. The secret is still live and change. What is the expectation from hiring manager? Revoke first and clean up second is the whole step. Security minded engineers neutralize the threat before hiding the evidence. Getting the order backward is the red flag. Let's understand this by everyday version, simplified version. You accidentally posted a photo of your house key online and you realize 3 minutes later. What's the first thing to do? Not frantically delete the post because anyone could have already taken the screenshot of it. The first thing is to change the lock. So the key in the photo opens nothing. Then you delete the post and tidy up. It is the same. The leaked key is copied the instant it's public. So you revoke it first and only after scrub it from the history. Delete the Good. Question number 10. Again, it is advanced scenario based question. The main branch CI has been failing for 45 minutes and three teams are. How do you investigate and resolve it? This is the scenario based question. So, what could be the right answer? First move is not technical. I announce it and take ownership. Main CI is red. I'm on it. So people stop duplicating efforts. Then I find the first commit that failed and read the full log to classify it. Is it a flaky environment issue or real code regression? I reproduce locally to be sure. If it's genuine regression, I revert the offending commit to unblock everyone fast. A revert is quick and pressable, and the author reapplies it properly later. Afterward, a short postmortem, what tests should have got this, and how to prevent this in the future. What could be the wrong answer? Silently digging into the code and trying to fix forward while three teams stay blocked and others start investigating the same thing in parallel. What are the hiring managers' expectations here? Communication and claiming the ownership before touching the code is a leadership signal. Then telling flaky environment from the real regression and preferring revert to unblock over a slow fix. Where to focus? Lead with the message, not the terminal. First, I post that I'm on it. It's this line that reads as a senior. Let's understand it by the simplified everyday version. Imagine the shared kitchen's main oven brags during the dinner rush, and three teams of cooks are stuck. The best chef doesn't quietly crawl behind the oven while everyone waits in confusion. They first shout, I have got this. Main oven is down. Hold on. So nobody else piles in. Then they check what changed last. And if new part broke it, they simply put the old working part back so everyone can cook again right now. And fix new part properly afterwards. In Git terms, speak up first, then revert to get everyone unblocked, then repair it. Your mission before episode 4, one step today, expert tomorrow. First step, your homework. Ask this question aloud without looking into the notes. You rebase a wrong branch onto main. Others already pulled it. What do? You have to answer why this is dangerous, how to revert it, how to fix it, and how to prevent it from happening. Second step, remember, Git is not memorizing thing. Git is the mechanism where multiple teams can work together, and you have to make sure that every change is going to packaging and deployment is the unbroken change. And third one, next episode, that is the Kubernetes interview masterclass. So where we're gonna see Kubernetes architecture, what is the role of each component in your Kubernetes architecture, deployment strategies, 10 interview questions, what are the hiring managers expectations, right answers and wrong answers. If you like the video, like, subscribe and motivate others to watch this, because this would be helpful to someone who is preparing for DevOps interview. Thank you.